third verse. Same as first. A little bit louder and a little bit worse. Just kidding. It is a little bit trickier this time, this third example, because we don't already have additive inverses, meaning two terms that add to 0. We're going to have, and we don't have an easy one where we only have to multiply one equation, because 4 does not magically turn into 10 when I multiply it by something, and -4 does not magically turn into 3, because they're not divisible by each other. So what's going to have to happen is we're going to have to multiply the top and the bottom equation by something, since we don't have additive inverses that are easy to make. We're going to have to work a little bit harder. We're going to multiply this whole top equation by that bottom coefficient. Now, I picked y, honestly, to eliminate y because 4 and 3 are smaller than 4 and 10. And I like to pick the smaller numbers to deal with. It makes my life easier. So I'm going to multiply the whole top equation by 3. And that's going to give me 12x minus 12y equals 24. And then I'm going to multiply the whole bottom equation by 4. So I multiply the top equation by the bottom coefficient and the bottom equation by the top coefficient, because look what happens when we do that. So 4 times 10x is 40x. 4 times 3y is 12y. Look at that. Additive inverses. Ka-chow. And then negative 19 times 4 is negative 76, I believe. Let me double check. Yep. All right. So now we've got a new version of our system of equations. Oops. And do we have additive inverses? Heck yes, we do. That was the whole point. Ha-ha. So now we're going to add straight down. Just add the like terms vertically so that we know what we have left that we have to deal with. 12x plus 40x. Oh, hi. That's 52x. Thanks. Negative 12y plus 12y. Oh, yeah. It's eliminated because it adds to 0. And 24 plus negative 76 is negative 52. All right, well, I need this little x by itself. It's being multiplied by 52, so I'm going to divide over here on the left. Well, got to do it to both sides of the equal sign. So we end up with x equals negative 1. Nice. Lowest CMOS, we did it. But we only got one of the variables. We got the x, we need the y. Okay, so you take that little x and you're going to plug it into one of the original equations. Just because they're smaller numbers and easier to deal with. And because they're smaller numbers and easier to deal with, I'm going to pick that top equation. Because I'm either lazy or efficient, whatever you want to think about it. Or maybe smart. Let's pretend it's smart. So I took that first equation, equation 1, and I'm going to take this x equals negative 1, and I'm going to plug it in here where the x is. So I'm going to take out that x, and I'm going to put in there what I just said x has to be. You know, I didn't leave myself a bunch of room. Let's try this again. I'm going to put in there what I said x has to be. And then I said specifically x is supposed to be negative 1. Okay, so now we're going to solve for y. Well, 4 times negative 1 is negative 4. If I want to get the y by itself, I got to get rid of the thing that's farthest away from the y. So I got to get rid of that guy out there, that negative 4. So I'm going to add 4 to both sides. So I got negative 4y equals 12. Now I got to get rid of this negative 4 in front of the y, and this time that negative 4 is being multiplied by y. So the opposite of multiply by negative 4 is divide by negative 4. So y equals, oh, you can't really see that there. y equals -3. Hey, we did it. -1, -3. Please go back and watch any of these videos more than once. Push pause, push play, rewind, etc. so that you get the idea of these processes. Okay, have a great time. Goodbye.